What's good? So today I'm gonna be going through where am I at? Where am I at? Roadmap. Right now I feel pretty confident in this upper half of this tree, right? But linked lists and trees are definitely and sliding window actually. I mean, there's a bunch of things to improve on here, but I know in particular I feel weakest in sliding window and trees and linked lists. So I'm gonna just be going to each of these problems, and instead of taking up the time trying to solve them myself, I'm just going to learn their patterns. So that means just for the medium problems, for the sliding window, and for actually all the I don't know how much time I'm going to be able to have to get through these, so I'll just focus on the medium problems for now. And so the other day I did a bunch of this just handwritten stuff. It's not going to be that interesting to look at, but I'm just going to be transcribing stuff. So right now I'm just going to start with doing the mediums with sliding window. Yeah, because best time to buy and sell stock, the best solution isn't even really a sliding window solution. So, okay. It looks like I've done this before. I'm going to see if this is looking right. Close that. Mostly correct, aimed at finding the length of the longest substring without repeating characters in a given string S, some minor issues and one significant mistake, undefined variable n. So this is important to do, right? Because I was transcribing stuff and then I realized that there was mistakes in the things that I was planting in my brain. So now I have to check every time just to make sure that I don't go writing stuff and committing things to memory that aren't actually useful. Okay, cool. So this works. So now what I'm going to do is I'm going to create a text file. Some tech interview advice. Let me save this actually. Close that. So we have this problem. Longest substring without repeating characters. Make this way bigger. Given a string S, find the length, longest substring without repeating characters. So if the string is ABC, ABC, BB, output should be 3 because ABC is the longest substring without repeating characters in both of these cases. Okay, cool. And then make this big. So now I'm gonna copy all this. That's not what I want. And so the solution, def length of longest substring, self S is a string, output is an integer, initialize variables, length of S, max length found, character map and left pointer, length equals len S, max length equals 0, char map is a dictionary, left equals 0, iterate through S with right pointer, so for right in range, the length, if the character at right is new or not part of the current substring. So if S right not in char map or char map S right is less than left, update the character's latest index in char map S right becomes right, so assign. So we're updating the character's latest index in char map. Okay, update max length considering the current window size. So max length equals the max between the current max length and then right minus left plus 1. Else move the left pointer past the previous occurrence of the current character. So left equals char map S right plus 1, and then update the character's index in char map S right equals right, and return max length. So what I'm gonna do is I'm gonna have this make it okay. Just don't change that. No. Okay, it's fine. I'll just manually change the input string back to S. So anytime I see input string, change it back to S. Okay, cool. So this should work then. All right. Let me just. So I don't think there's any real good way to make this more interesting to look at, but I'm just gonna be transcribing this. So I guess I can make it take up more of the screen. Okay. current character is in the map and its index is within the current substring. Current char and char index. Oh, char whatever, char index map. Char index map. Current char star index. So if the current character is in the map and its index is within the current substring, move the start to the right of the repeated character's last occurrence. Char index equals char index map current char plus 1. Update the current character's index in the map. Update the max substring length if the current window is larger. Max substring length equals max between the current max substring length and end index minus start index plus 1. Return max substring length. Then at the end of the for loop, we return the max substring length. Okay, so for this problem, is this off? What? Oh man, this is not good. I've left my mouse plugged in, supposedly charging, but this charger hasn't been working all day, and it still doesn't seem to work. This charger, since I got it, hasn't worked. This is okay. Okay, cool. All right, it's something, I don't know. At least I can see. So, but this is not gonna be good if I don't. Okay, for now, let me just focus on this. So longest substring without repeating characters. Given a string S, find the length of the longest substring without repeating characters. Class solution, def, length of longest substring, self, as is a string, and the output is an int. So we define the total length of the input string, so total length equals len s. We track the length of the longest substring without repeating characters, so max substring length is initialized to 0. We create a map or a dictionary to map characters to their latest index in the substring being considered. So char index map is an empty dictionary, and we initialize a variable to hold the start index of the current substring without repeating characters. So start index is initialized to 0. And then we iterate through the string with our end index counter marking the current character's position. So for end index in range total length, current char equals s end index. So it's going to start at 0 if the current character is in the map and its index is within the current substring. So if current char in char to index map and char to index map current char is greater than or equal to the start index. So for now, let's skip it, right? Because on our first pass, that's not going to evaluate to true. So regardless of that, we update the current character's index in the map. So char to index map current character, which for, where's the example? Am I going to be able to use this mouse? This is amazingly bad. I really don't want to have to drive to Best Buy. Why isn't this working? Okay. I think it was just plugged in poorly over there. I hope that's all it was. So, I mean, there's a light on, so cool. So regardless, we update current characters map. So let's check out what the example is. The example case is ABC, ABC. Okay. So on our first pass, char to index map current char, which is A, equals n index, so 0. And then we update the max substring length if the current window is larger. So max substring length equals the max between the max substring length, which is currently 0, and n index, which is 0, minus start index, which is also 0, plus 1, so 1. So max substring length is currently 1. We go back through the for loop. Now end index is 1, so current char is B. Let me make this wider. So current char is B. If B is in our char to index map, which it's not, so that's not going to run. We just update the current character's index in the map. So char to index map B equals n index, which is 1. So now char to index map looks like A0, B1, and then we update the max substring length if the current window is larger. So we find the max between our max substring length, which is currently 1, and end index, which is 1, minus start index, which is 0. So 1 minus 0 is 1, plus 1, which is 2, which is greater than 1. So our max substring length is now 2. We iterate through it again. Current char is C, and end index is 2. If current char in char to index map, which it's not, so that doesn't run, update the current character's index in the map. Char to index map C equals 2. So char to index map now looks like A0, B1, C2. Max substring length is going to be n index 2 minus 0 is 2 plus 1, so 3, which is greater than 2. Come through this again. Now we're on A. N index is 3. Current char is A. If the current char in char to index map, which it is, and char to index map A is greater than or equal to our start index, which is also true because char to index A is 0 and start index is 0. So move the start to the right of the current repeated character's last occurrence. So now start index equals char to index map current char, which is A, plus 1. So our start index now moves from 0 to 1. We update the current character's index in the map. So char to index map A equals 3. And we update the max substring length if the current window is larger. So max substring length equals the max between our max substring length, which is 3, and our end index minus start index plus 1. So right now end index is 3, start index is also 3, so 3 minus 3 is 0, or sorry, no, our start index is 1. So 3 minus 1 is 2 plus 1 is 3. So regardless, our max substring length remains 3. And we're going to iteratively go through that, but I understand the process now. Okay, that makes sense. Let's save this. And actually, I think I'm going to talk through it before I transcribe the next one. But for now, let me just save this longest substring without repeating characters. And I'm going to save this to sliding window. I'm going to get rid of it. Which probably isn't the greatest idea, but it's just normalizing it because that's how the others look. So now let's move to the next one. Whatever. Row map, sliding window, longest repeating character placement. So in this problem, you are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operation. So if our input is s equals capital A, B, k is 2, our output is 4. Explanation: replace the 2 A's with 2 B's or vice versa. And if our input is capital A, B, B, A, and k is 1, then our output will be 4 because we replace the 1A in the middle with B and form A, B, A. The substring B has the longest repeating letters, which is 4. There may exist other ways to achieve this answer too, which you could just think if you change that first B to an A, you have 4 A's. So again, reading the problem, you're given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Okay. So if we look at the solutions, Python 3, this was what this guy came up with. And what we're going to do is we're going to copy this. Not that. Right here. The code snippet you provided is indeed a practical and efficient solution to the longest repeating character problem, especially for beginners. It uses a sliding window approach combined with a character frequency count to determine the longest substring that can be achieved by replacing up to k characters. However, the code has a small error in the logic that checks when to shrink the window. Let's clarify the approach and correct the mistake. Approach: maintain a frequency count. Use a counter to keep track of the frequency of each character within the current window, the substring being considered. Sliding window: expand the window to the right by adding one character at a time into consideration and updating its count in the counter. Find the largest count. Keep track of the count of the most frequent character in the current window. This is because to achieve a substring of equal characters after replacements, you ideally replace other characters with the most frequent character. Check if replacement is feasible. The length of the current window minus the count of the most frequent character gives the number of replacements needed. If this number is greater than k, it's time to shrink the window from the left. Otherwise, it's possible to include the character in the substring. Update the maximum length. Keep updating the maximum length of the substring found that can be performed by replacing up to k characters. Corrected code. There's a subtle issue in the condition to shrink the window. The window should shrink only when the condition window length minus the largest count greater than k holds true, indicating that more replacements are needed than allowed. The original code does this comparison incorrectly. Here's a corrected and slightly optimized version. This version correctly manages the window size by ensuring that it only includes substrings where the number of characters to be replaced does not exceed k. It's an optimal solution for beginners as it balances between simplicity and efficiency, introducing key concepts like sliding windows and frequency counting in a clear manner. Okay, let's see if it works. Back here. Okay, it works. And so I'm just going to submit just to check the edge cases. Okay, cool. So now what I'm going to do is add clear and concise but descriptive comments where helpful. Okay, here's the same solution with added comments for clarity. Cool, cool. Just making sure it doesn't change anything unnecessarily. It's got this dot counter collections. No. Hold on. Array equals collections dot counter. No. You shouldn't be importing anything, dude. Why is this? So we're going to use a dictionary to manually keep track of the frequency of each character in the current window, increment the character count when expanding the window to the right, and decrement when shrinking the window from the left. Continuously update the count of the most frequent character in the current window, and adjust the window size based on the allowed replacements k. Here's how you can implement it. Okay, already these comments are too verbose. Okay, so now let's just check this to see if it works. Run it. Cool. Does it work on the edge cases? Cool. Slightly worse runtime, but whatever. So now what I'm going to do is I'm going to make a text file for this. I'm going to manually write the problem statement just to ingrain it in my brain more. So this is longest repeating character replacement. are given a string S and an integer k, you can choose any character with string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Cool. And then this is the code. Cool. All right, now I'm going to transcribe this by hand, make it stick in my brain. So max len equals 0, the maximum substring length found. Largest count, I guess I'll put this here. Largest count equals 0, highest frequency of a single character in the window. Char frequency is an empty dictionary. Track frequencies of characters in the window. So left equals 0, start of the sliding window. And then for right in range length of S, expand the window to the right. Char frequency S right equals char frequency dot get S right 0 plus 1. So what that's doing is it's looking in our char frequency dictionary. It's checking. So char frequency dot get S right's value. If it doesn't have a value, it initializes it as 0, and then it's adding 1 to whatever the result of that is. So if S right has a value, it plus 1, or if S right doesn't have a value, it starts at 0, and then 0 plus 1 is 1, and it's assigning that to S rights. So the current character of our, our right pointer is pointing at in S. So whatever character that is the key in our char frequency dictionary, and its frequency is assigned the value. We increment it essentially. And then largest count equals the max between whatever largest count currently is and char frequency S right's value. So largest count started at 0. Now I'm remembering I forgot to do the pass through, but it's fine. So I'm doing it now. Largest count starts at 0. Char frequency S right as of now is currently 1. So now our largest count is 1. Okay. If more replacements are needed than K, shrink the window from the left. If right minus left plus 1. So if right minus left plus 1, so right now right is 0, left is 0, so 0 minus 0 is 0 plus 1. So if 1 minus the largest count is currently 1. So if 1 minus 1 is greater than K, which for all intents and purposes right now we're assuming K, I think is 1 for the example. Where are we? Yeah, so right now, 2. So if 0 is minus, so if 0 is greater than K, which it's not, but if it were, then char frequency S left. So we decrement our char frequency for the leftmost character, and then we increment our leftmost character pointer. So, but that doesn't evaluate to true for right now. We're going to get out of that, and we're going to update the max substring length. Max len equals the max between max len, which is it? Yeah, we initialize it to 0 at the top, and then right minus left. So 0 minus 0 plus 1. So right now our max len is 1, and we keep iterating through this for loop for all of the length of S, our input string. Okay. So max len equals max len right minus left plus 1. Return max len. Okay, great. So again, just reiterating the whole thing. Longest repeating character replacement. You are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. So class solution, def character replacement, self, s is a string, k is an integer, and our output should be an integer. First, we declare max len equals 0, so that's the maximum substring length found. Largest count equals 0, that's the highest frequency of a single character in the window. And then char frequency is an empty dictionary, which we use to track frequencies of characters in the window. Left equals 0, that's the start of the sliding window. For right in range, length of s, expand the window to the right. That's for our for loop. So char frequency s right equals char frequency dot get s right 0, or I'll say s right comma 0 plus 1. And again, what that's doing, so char frequency dot get, the dot get method on a dictionary, the first value we pass it is the key, and the second value is what we would initialize that key to if it doesn't exist. So char frequency dot get s right comma 0 is checking to see if s right within our char frequency, if it has a key s right. If it doesn't, it initializes its value to 0, and then we plus 1, we increment it and assign that to char frequency s right's value. Largest count equals the maximum between our current largest count and char frequency s right's value. If more replacements are needed than k, shrink the window from the left. If right minus left plus 1 minus largest count is greater than k, char frequency s left minus equals 1. So we decrement it, and by doing so, we decrement it, and then we increment the left pointer. So again, if more replacements are needed than k, shrink the window from the left, char frequency s left. Okay, so yeah, so we're decrementing the value of that s left because we're moving it out of the window. And then after that, we update the max substring length. So max len is now the maximum between our current max len and right minus left plus 1. And at the end, we return the max len. So let's look at our example and think about how the data will pass through here and how this will operate. so let's widen this enough, or at least make it smaller so we don't have any wrapping. Okay, so our input is S equals capital A, B, A, B, and K is 2. So max len 0, largest count equals 0, char frequency is an empty dictionary, and left equals 0. So for right in range length of S, so length of S in this example is 4. So from 0 to 3 will be what right will act as. Char frequency S0 on our first pass. So S0 is A, and this will be equal to char frequency dot get S right, which is A, or 0. So since char frequency currently doesn't have an A key, we create an A key with a value of 0 and we add 1 to it. So now char frequency A, its value is 1. Largest count equals the max between largest count, which is 0, and char frequency S right, which has a value of 1. So now largest count equals 1. If more replacements are needed, then K, shrink the window from the left. If right minus left, so if right now it's if 0 minus 0 plus 1, which is 1, minus largest count, which is also 1. So if 2, right? Am I thinking about that right? Right is 0, minus left, which is 0, plus 1. So 1, oh, sorry, minus largest count. So it's 1. So 1 minus 1 is 0. So if 0 is greater than K, which is 2, then, so that doesn't evaluate. We update the max substring length. Max len equals the max between our current max len, which is 0, and right minus left plus 1. So currently right is 0, left is 0, plus 1 is 1. So max len is 1. On our second pass, right is now 1. Char frequency S1, which is B, and we make that, we give it a value of 1. Largest count equals the max between our current largest count, which is 1, and char frequency S right, which is also 1. So largest count is still 1. If more replacements are needed, so if 1 minus 0, which is 1, plus 1, which is 2, minus largest count, so 2 minus 1 is 1, which is not greater than K, so that doesn't evaluate to true. Let's update the max substring length. Max len equals the max between our current max len, which is 1, and 1 minus 0, which is 1, plus 1. So now max length is 2. On our next pass through, right is 2. Char frequency S right. So S right is capital A, which already has a value of 1. So we just, so when we do char frequency dot get S right comma 0, it doesn't reinitialize it to 0. It sees, okay, S right has a value of 1. So we're just going to add 1 to it. So now char frequency A equals 2. Largest count equals the max between our current largest count, which is 1, and char frequency S right, which is 2. So our largest count is now 2. If more placements are needed, then K, shrink the window from the left. If right, which is 2, so 2 minus 0 is 2, plus 1 is 3. 3 minus largest count, which is 2. So 3 minus 2 is 1, which is not greater than 2, so that doesn't evaluate. Update the max substring length. Max len equals the max between max len, which is currently 2, and 2 minus 0 plus 1, which is 3, so max len is 3. Again, range, right is now 3. Char frequency S3, which is B, equals char frequency dot get B comma 0, but B already has a value of 1, so this adds 1 to it. So now char frequency B equals 2. Largest count equals the max between our current largest count, which is 2, and char frequency S right, which is 2. So largest count is still 2. If more placements are needed, then K, shrink the window from the left. So if 3 minus 0, which is 3, plus 1 is 4, minus largest count, which is 2, is greater than K, which it's not. So that, for our first example, at least, that never evaluates to true. Hypothetically speaking, if we got to evaluate that to true, what we would do is we would slide the window. So char frequency S left, which would be our first character in the string, we decrement its value, and we increment the left pointer. So we slide the window. And again, we update the max substring length. Max len equals, so for our current example, max len equals the max between our current max len, which is 3, and 3 minus 0, which is 3, plus 1, which is 4. So max len is 4. And now we've gone through the entire loop and we return max len, which is 4. And we explanation replace the 2 A's with 2 B's or vice versa. So we actually never made the replacement. We just kept track of what our maximum length is if we so chose to make a replacement, right? So cool. So I'm going to save this. Let's come back to LeetCode roadmap. Permutation in string. So permutation in string, given two strings S1 and S2, return true if S2 contains a permutation of S1 or false otherwise. In other words, return true if one of S1's permutations is in the substring of S1. So for example, if S1 is AB and S2 is, I don't even know how to pronounce that, but we'll say just EIDBAOOO, output is true because S1 contains one permutation. Sorry, S2 contains one permutation of S1. So BA is a permutation of AB. And in our example 2, S1 equals AB, S2 equals EIDBOAOO, which outputs false because it doesn't contain a permutation. And just so I'm on the same page, define permutation. I just think of it as like a transformation away, especially one of several possible variations in which a set or number of things can be ordered or arranged. Got you. Where am I? I am right here. Okay, so let's look at the solutions. Python 3. So somebody did this. The optimal solution, we can use an auxiliary variable to count a number of characters whose frequency gets to 0 during window sliding. That helps us to avoid iterating over the hash map for every cycle tick to check whether frequencies turn into 0. So I'm noticing this is the second time I've seen this counter being used, which I don't really understand this counter object. I understand it has to do with an import. So what I'll do is, but otherwise, if not this match, I don't even know what that is. So how optimal is this though? Is this a better runtime? Here's what I'm going to do. Since that's not very clear, I'm going to copy this. For the problem of determining if one string is a permutation of a substring and another string, a beginner-friendly and optimal solution involves the sliding window technique combined with frequency counts. The key is to compare the frequency count of characters in S1 with the frequency count of characters in a sliding window of S2 of the same length as S1. If at any point these two frequency counts match, it means S2 contains a permutation of S1. Approach. Frequency count of S1, create a frequency count of all characters in S1, sliding window on S2, iterate over S2 with a window size equal to the length of S1. This window will capture potential permutations of S1 within S2. Frequency count of window, maintain a frequency count of characters within the current window of in S2. Compare counts after each step or when the window is adjusted. Compare the frequency count of the current window with S1's frequency count. If they match, S2 contains a permutation of S1. Adjust the window. If the window size exceeds S1's length, increment the start of the window to keep its size constant, updating the frequency count accordingly. So this is the implementation. And so it initializes it as an array with 26 zeros in it for the alphabet. So explanation: we use a fixed length sliding window to explore S2, looking for any sequence of characters that match the frequency count of characters in S1. Two arrays of length 26 for each letter of the English alphabet track the frequency counts. This simplifies to a direct comparison of arrays to check for a permutation match. We slide the windows across S2, updating the counts and checking for a match after each step. The solution is both beginner-friendly and efficient, utilizing fundamental concepts of sliding windows and frequency counts with complex data structures or algorithm. I'm trying to remember exactly what the ORD method does. The ORD function in Python takes a single Unicode character as its argument and returns its corresponding Unicode point value. This code point value is an integer representing the Unicode character in memory. For example, the Unicode point for the character A is 65, and for lowercase a is 97. Okay, in the context of the solution to the problem, ORD is used to convert characters to their integer representation. This conversion is useful for indexing into an array where each index corresponds to a character. Since the problem statement limits the characters to lower English letters, subtracting the ORD value of A from any character's ORD value maps A to 0, B to 1, Z to 25. This mapping allows for a compact representation of character frequencies in a fixed size array of 26 elements, where each element counts the occurrences of a particular character in the strings. I'll say simple way to solve this problem without ORD. Yes, you can solve the problem without directly using ORD function by leveraging Python's dictionaries to track the frequency counts of characters. This approach doesn't require converting characters to their ASCII values or managing fixed size arrays. Instead, you can directly compare frequency dictionaries of S1 and the current window in S2. Approach using dictionaries. Character frequency count for S1. Create a dictionary to count the frequency of each character in S1. Sliding window on S2. Iterate over S2 with the window size equal to the length of S1. Tracking the frequency of characters within this window using a dictionary. Compare dictionaries. Compare the frequency dictionary of the current window against S1's frequency dictionary. If they match, it means a permutation of S1 exists in S2, and then slide the window. Adjust the window over S2 by adding the next character and removing the leftmost character from the frequency count, maintaining the window size. So this approach makes a lot more sense to me just looking at it. So this solution avoids using ORD by directly comparing character frequency dictionaries. It's a bit more flexible and easier to understand for those unfamiliar with character encoding schemes like ASCII or Unicode. However, it might be slightly less efficient than using fixed size arrays due to the overhead of dictionary operations, but for most practical purposes, especially with the constraints of S1 and S2 consisting of lowercase English characters or lowercase English letters, this difference is negligible. Okay, great. So let's test this to see if it works. Coming back here. I don't want to override that, so copy that, paste, and make sure the indentation is right. That looks right. So let's run it. Runtime error. Solution.check inclusion takes 2 positional arguments, but 3 were given. Hold on. Just adding arguments, chat. That's what we doing now. We adding arguments. Just like my ex-girlfriend. Just adding arguments for no reason. It's a cheap joke. All right. So let's bring this up here. Run it. Okay, let's submit it to make sure it passes the edge cases. Okay, great. Okay, cool. So, not optimal for memory, but pretty optimal for runtime. Regardless, it's fine. So now I'm gonna come and go back to the description and transcribe this in text. Save this real quick. Permutation and string. Getting two strings, S1 and S2. Return true if S2 contains a permutation of S1, or false otherwise. In other words, return true if one of S1's permutations is the substring of S2. Cool. And then copy all that, come back here, paste it in, and then full screen that, zoom it in. Actually, it's a little too zoomed in. It's kind of easier to read for me if I zoom it. That's good. So I'm going to transcribe it by hand, but actually first I'm going to read it out. So we have class solution def check inclusion self. S1 is a string, S2 is a string, and our output is bool. If length of S1 is greater than length of S2, return false, because obviously S2 cannot contain a permutation of S1 if it's shorter than S1. Frequency count of characters in S1 and the first window in S2. So S1 count is an empty dictionary. Window count is an empty dictionary. Initialize frequency counts. So for char in S1, S1 count char equals S1 count dot get char 0 or char comma 0 plus 1. So again, we're looking at all the characters in S1 and we're assigning each of their values to the corresponding key of the character in our S1 count dictionary. If the character doesn't exist as a key in the dictionary, we initialize it to 0. Otherwise, we increment its value. And for char in S2, so from the beginning up to the length of S1, which is interesting. I gotta ask why for char in S2 up to the length of S1. Okay. Oh, I see. That's just making sure that our window remains. We start the window by just looking at the length of S2 that is equal to the length of S1, right? So if S2 has 5 characters and S1 has 2, this just makes sure that this for loop only runs for the first 2 characters. So for char in S2 up to 2. Okay. Window count char equals window count dot get char 0. All right, so it's counting our window. Compare initial window. If S1 count is equal to window count, so if they're the same, return true. Slide the window across S2. So if they're not the same at the beginning, then we're going to start sliding the window. For I in range, length of S1, length of S2. So since we already did that initial window check, we start at the index corresponding to the length of S1. So that would be the character right after that. So in our example, S2 has 5 characters, S1 has 2. So we start at index 2, which will be the character just after what we checked in our initial window check, up to, but not including the value of the length of S2. So if S2 is 5, then we're going up to index 4, which would be the last character of S2, since we started the 0 index. start char equals S2I. So in our example, that's S2 minus the length of S1. So interesting. So 2 minus 2 is 0. So our start char is the first character in S2. And char equals S2I, which is S2 2. So we are starting at the beginning of S2. And our window is the same size. Remove or decrement the starting character of the window if window count start char is equal to 1. Delete window count start char, else window count start char minus equals 1. Okay, so let's think about this with the example. In our example, window count start char, in this case start char is E. So if E in our window count is equal to 1, which it is after our initial tests or setup up here, so then we just delete it from our window count. Add or increment the new character at the end of the window. So window count D is going to be equal to, so we initialize it to 0 and then we add 1. So now D is 1. Check if the updated window matches S1's frequency count. If S1 count is equal to window count, so right now S1 count is A1, B1, and right now window count is I1, D1. So if they were equal, then we return true, but they're not. So we just keep doing this. And on our second pass, I is 1. Sorry, no, I is 3. Yes, I is 3. Start char equals S2, 1, and char equals S2, 3. So our window now is IDB. And we check again. If window count I is equal to 1, we delete it, which it is, so we delete it. And add or increment the new character at the end of the window. So window count B becomes 1, and is A1, B1 equal to D1, B1? No, it's not. So again, we come here, or we come where? Right here. So I now is 4. 4 minus 2 is 2. So S, right? Am I thinking about that right? Yeah. So S2. So D is the start of the window. N character is S2, 4. So 0, 1, 2, 3, 4. So that's A. So DBA is our window. Remove or decrement the starting character of the window. Window count start char is equal to 1. It's true, so delete it. And add or increment the new character at the end of the window. Window count A equals window count dot get. So window count A is now 1. Check if updated window matches S1's frequency count. So does A1 B1 equal B1 A1? For all intents and purposes, in this case, yes, it does. So now we return true. We found the permutation. Okay. So now I'm going to transcribe this by hand. S1 and the first window in S2. This is gonna fit 3, 3, 3. It's gonna be a tight fit. Initialize the frequency counts for char and S1. S1 count char equals S1 count dot get char comma 0 plus 1. Char in S2 up to length of S1. Window count char equals window count dot get char 0 plus 1. Compare initial window. Slide the window across S2 for I range length of S1, length of S2. Start char equals S2 I minus length of S1 and char equals S2I. Remove or decrement the starting character of the window. If window count start char is equal to 1, del window count start char else window count char decremented minus equals 1. Add or increment the new character at the end of the window. Window count nchar equals window count dot get nchar comma 0 plus 1. Then we check if the updated window matches S1's frequency count. If S1 count is equal to window count, return true. Otherwise, if we make it out of that loop, we're going to go ahead and return false. Cool. How am I doing on time? Time for dinner, really. Don't have time for another one. But I'm feeling good about this. So let me go ahead and save this. And permutation and string. Sliding window, yeah. And I already went through the walkthrough with the example. So cool. Yeah, I definitely didn't do as many as I kind of hoped. But I mean, being reasonable, I kind of knew that's all I was going to get through. So I guess tomorrow on to really, I'm going to start off tomorrow just getting all these linked lists, at least the mediums. I've already done the easies, so I'm just going to get all these into my head. And if I have time, pretty much like all of these trees except the first two I've already written out.